Okay, so for number 18, they want you to find the inverse. So remember, when you're dealing with a real life problem, you just get rid of that part of it and just say A equals. Now 160 over 2 happens to be 80, right? So I can reduce it like that. And I'm solving for V now, so I'm going to divide by 80. And then I have E over 80 equals V squared. So now I'm going to take the square root of both sides. And so that leaves me with V equals the square root of E over 80. And there's your inverse. Okay, so with real life applications, we do not switch the variables like we do with X and Y. So this would be V of E equals the square root of E over 80. Okay, and for part B, they want you to evaluate at, what is it, at 2,000. If the energy, oops, forgot the parentheses, is 2,000. Okay, so I can reduce by 10, so I have that, and 200 over 8 is 25, so this is square root of 25, so then that gives me 5, and V is velocity, so it's meters per second. Alright, for number 20, you have the relationship between Celsius and Fahrenheit. So they want you to find C in terms of F, so that means they want you to find the inverse of this equation. So we're solving for C now. So the first thing we do is subtract 32. So that's gone. So now I have F minus 32 equals 9/5 C. So to get rid of the 9/5, I'm going to multiply by the reciprocal of 9/5. So I'll just put it over here, 5 over 9 and 5 over 9. Now be careful, you have to remember you have to have parentheses. So the 9 over the 9 is gone, the 5 over the 5 is gone. So now C is by itself, and it equals, now you can leave it like this, 5/9 times the quantity of F minus 32. You don't have to distribute, so this is fine. Okay, so for 22, they want you to find the radius of the ball, of the sphere, in terms of its mass. So we want the inverse of this function. So again, remember, when we're dealing with real life problems, we're gonna eliminate that for now and put m by itself. And so we're going to divide by 31 because we want r by itself. Okay, so now I have m over 31 equals r squared, r cubed. So we're going to take cube root of both sides. So now I have, I'll just work up here, I have r equals cube root of m over 31. So now I'm going to put it in function notation, so I'll put r of m equals cube root of m over 31. And that's the inverse. Alright, so for number 24a, I took the point of inflection or inflection point, and that's my HK. It's 4, 2. And then I picked one of the other 2 points, and I just happened to pick 5, 4. I could have picked 3, 0 if I wanted to. And then I set up the equation for a cube root function, and I know it's cube root because it has that S shape, okay, that kind of S-y shape. So now 4 is Y. I'm trying to look for A. X is 5, H is 4, and K is 2. So 5 minus 4 is 1, so cube root of 1 is 1, so that's kind of nice. So minus 2 worked out nicely. So now I have 2 equals A. So my function will be f of x equals 2 times the cube root of x minus 4 plus 2. Okay, for part B. Alright, so for B, again I identified the HK, that's your starting point on the square root function, and your xy. Again, I just looked at the point that they marked, and those are the coordinates. Now, I'm using the B equation on this one because it's opening to the left, okay? And in most cases, when the square root function opens to the left, the B equation is easiest to deal with. So y is negative 3, B we're looking for, x is negative 5, and h is negative 3, so minus, so negative 3 makes it a positive 3. minus 5. So we're going to add 5. Okay, and then inside the parentheses I have, well, on the left side I have 2 equal square root. Now negative 5 plus 3 is negative 2, so it's negative 2b. I'm going to square both sides to get rid of the radical. So then, let's see if I could, no, it doesn't go anymore. So it's going to go 4 equals negative 2b, right? So I'm going to divide by negative 2. So b equals negative 2. So my equation is going to be f of x equals the square root of negative 2 inside parentheses, or not parentheses, inside the square root, x plus 3, extend this little bar a little bit more, minus 5. So that's the equation for the b part. Okay, so number 26, you have to describe the transformation. So we would say something like, compared to the equation, the parent function y equals cube root of x, this one has reflected over x-axis. It has a vertical compression, and why compression? Because 2/3 is less than 1, by a factor of 2/3, and it has a translation 3 units down. So 28, compared to the function f of x equals square root of x, compared to that one, this one has a reflection over the y-axis because the b is negative. It has a horizontal stretch because remember b is reciprocal, so 2/3 reciprocal is 3/2, which is bigger than 1. Horizontal stretch by a factor of 3/2, and then it's translated 1 unit right and 2 up. Alright, number 30, you're going to compare it to the parent function y equals x squared. So compared to that one, this 1/2, notice how the 1/2 is inside the parentheses and it's being squared. So right now the way it is, this is b. So you're going to say it has a horizontal stretch by a factor of 2. And it's translated 1 unit right and 3 down. Okay, because h is positive 1 and k is negative 3. Now, if you take out the 1 squared outside of the parentheses, so you have to square it first, it becomes 1/4. So I can rewrite this as, if I square the 1/2, I could rewrite it as 1/4, oops, like this, x minus 1 squared. I can do that, and it's still the same function, it's the same one. I took out the 1/2. You could instead say that it has a vertical compression by a factor of 1/4. So either one of these is right, either this one right here or this right here. You could choose whichever way you want to write it, and they're both right. Okay, so number 32, there was definitely a typo on that. The negative 9 should be outside. I forgot the parentheses. Okay, so compared to this graph, okay, the one they gave you has a reflection over the y-axis because the b is negative, not the a. The b is negative, so it's reflection over the y-axis. There's a horizontal stretch because we take the reciprocal of 1/2 by a factor of 2. And then it translates 3 units left and 9 down. Alright, for part A of number 34, they want the end behavior. So in order to do that, you have to look at all the x's and multiply together. So this is x squared for the first factor and then x squared for the second factor. So it's x to the fourth. So it's a positive A with an even power. So that means it's going to go up, up. Okay, so we say as x goes to infinity, f of x goes to infinity, it goes up. And as x goes to negative infinity, as it goes to the left, the function still goes up. Okay? For part B, they want you to find the x and y intercepts. So for B, the x-intercepts are what makes each factor a 0. So what makes that a 0 and what makes that a 0. So the x-intercepts are 3 and negative 4. For the y-intercept, we replace the x with a 0. So you get 0 minus 3 squared and 0 plus 4 squared. So then that gives you negative 3 squared, so that's 9. And this gives you 4 squared, so that's 16. So that's going to be 144, the y-intercept. For part C, they want you to determine whether the graph is crossing or tangent at the x-intercepts. Well, both of them have an even multiplicity, right? Up here. Both of them have square. So both are tangent. Both x-intercepts. And then we have to graph it. So we're going to do a simple sketch. So, end behaviors are up, up, so this is going to come this way, and they bounce off of each of the zeros, and we know the y-intersect is 144, so there's no way we're going to go to 144 right here, but we just know it bounces off, and then it bounces off, like that. Okay, for part E, they want the domain and range, so remember for any, oops, E not D, for any polynomial, the domain is all reals. And the range, in this particular one, notice that there's nothing down here. The points start on y equals 0 and then they move up. So then the range is all y's, all y's greater than or equal to 0. Okay, so there's your domain and your range. So 36 is negative x to the fourth because I've got an x cubed right here. Cubed and then an x, so it's negative x to the fourth, so this one's coming down, down. Okay, so it would be just like this one, except they would both be negatives, negative infinities. For B, x-intercepts are 0 and negative 6. Y-intercept, you'd have negative 0 times 0 plus 6 cubed. Well, 0 times anything is 0, so the y-intercept is 0. And then C, the multiplicity of both of them is odd, so they are both crossing. The graph crosses at both x-intercepts. For D, we're going to sketch. So at negative 6, it does like the cube curve, so it's something like this. It comes back down through 0, 0, and it comes back down. So that's what it looks like. Now, domain and range. For this one, domain is all reals. Okay, so that one we know. For any polynomial, the domain is all reals. The range, on the other hand, we would have to know this number up here. So you need a graphing calculator. So this is, right now, you need a graphing, I'll put a G calculator. Okay, right now it's kind of a question mark. So I would not ask you this on a test. Okay, so we're rewriting or writing a transformation for this function, cube root of x. Those are the things they tell you, vertical compression, translation, and that's about it. So we're going to say f of x equals 1/4, because it's vertical compression, so it's a, and then h is 5, and k is 2, and that's it.